Hello guys, my name is John Michael Reyes and I'm back again for the chapter 5 tutorial, and somewhat I'm gonna teach you, and in order for you to learn the basic knowledge about the chapter 5, then the chapter 5 is all about Ethernet, then other stuff. Then the OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. Ethernet is now predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. The Ethernet protocol standards define many aspects of network communication, including frame format, frame size, timing, and encoding. When messages are sent between hosts on an Ethernet network, the host format the messages into the frame layout that is specified by the standards. Because of because Ethernet is comprised of standards at these lower layers, it may be best understood in a reference to the OSI model. The OSI model separates the data link functionalities of the addressing, framing, and accessing the media from the physical layer standards of the media. Ethernet standard defines both layer 2 protocols and the layer 1 technologies. Although Ethernet specifications support different media bandwidths and other layer 1 and layer 2 variations, the basic frame format and address schemes is the same for all varieties of Ethernet. This chapter examines the characteristics and operation of Ethernet as it has evolved from a shared media connection based data communication technology to today's high bandwidth and full duplex technologies. Then let's go. Hello guys, and this is the first activity of the chapter 5. Then would be the MAC and the LLC sublayer. Then there are some definitions in here, so I'll teach you how to answer this one. So, controls the network interface card through software drivers. That would be an LLC. Then works with the upper layer to add application. We all know that the MAC address is in the sublayer and the LLC is in the upper layer, so it would be LLC. Then works with the hardware to support the bandwidth errors bits frame. That would be a MAC. Then controls the access through signaling and physical with the word physical. That would be a MAC. Then support Ethernet technologies by using CSMAD or collision detection, or CSMA or collision avoidance. That would be a MAC also. Then remains relatively independent for physical equipments. That would be LLC. So let's check. As you can see, all of my answers are correct because it is simply easy, and other stuff is somewhat I've already did this once, I think, because our prof required us to. Then that's all. Then hello guys, we're back from the video, and this time we are gonna answer this one. This is one I'm gonna teach you because the meaning is already in here, so I can teach you what is the meaning of that and the other stuff. Then first, let's answer this one. Then uses pad to increase and other stuff. That would be a header. I think yes. I think it's a header and data. Then describe which higher layer protocol has been used. Then it would be type. Then after that would be the frames originating NIC or interface MAC address. That would be the source address, obviously because of the word originating and the NIC. Then assist the host by determining if the frame has been received as address. That would be a destination address, because when the frame arrives in the destination address, it parse or it gives us an ICMP or somewhat like that, a message if the PDU or packet has been, or the frame has been delivered. So notifies destination to get ready for a new frame. That would be the preamble, because there's a definition in these previous lessons that the preamble is the one that notifies the destination to get ready for a new frame to receive. Then synchronize sending and receiving devices for frame delivery. That would be a start of frame delimiter. In order to the start frame delimiter simply synchronized, that would be the keyword. Then the last one that detects errors is the FCS, or the frame check sequence. And as you can see, all my answers are correct, and it is pretty simple. Then let's proceed to this figure 2. Then the figure 2 would be this one. The activity, this one is, as you can see, there are bytes, and these are the somewhat just the lots of all the things. Then first would be the preamble, then start frame delimiter, then the destination, then the source, then after that would be the length, then header, then frame check sequence. Then as you can see, it's just so easy. If you already know, or if you've studied hard for this, it would be easy. Then let's proceed to another activity. And guys, we are back on the activity, and this activity is called switch it, and this one is somewhat how we're gonna transport, or what will be the answers if where will the switch forward the frame. Then as you can see, there are mock tables, frames, and other stuff. So let's try to answer it. Then as you can see in here, determine how the switch forwards a frame based on the source MAC and destination MAC address and information in the switch MAC table. Answer the question below. So you can see these are the switch. As you can see, the version of the switch is 2950 series catalyst. Then there are 12 ports and other stuff. Then as you can see in here, in the MAC table, the destination port is OD and the source port is OA. And as you can see, MAC table, the OD and the OA are already in the MAC table, so it would just go to the OD, to the FA7, then that would be only if a frame is a unicast frame and will be only in the specific port, because we all know that, as you can see in here, it is already in the MAC address. So let's check. As you can see, my answers are correct. Then let's try another one. Then let's try another one. Then as you can see in here, then the source MAC address would be OD, and as you can see, there are no OD in here. Then the destination MAC is the broadcast address, so it would go to all ports, the FA1, FA3, FA5, and FA9. It would then go to FA7 because FA7 is already the OD, so it would go to the switch adds the MAC address to the MAC table because there's no OD. Then it would frame a broadcast forward to all ports. Then let's check. So you can see my answers are correct because it is somewhat easy. Then let's go to another one. Then we are back, guys. This is the activity, another activity for the chapter 5, and as you can see, these are the frame forwarding method. Then in here, the chapter 5 would be just like this, buffer frame until the full frame has been received by the switch. Then the answer would be star and forward because full frame has been received by the switch. As you can see, star and forward just like that. Then check the frame for errors before releasing it out of its ports. Is the full was not received, the switch will discard it. That would be star and forward again because the star and forward always check the full frame, and if somewhat the frame is not complete, it will discard it. Then no error checkings on frame is performed by the switch before releasing the frame out of its port. That would be a cut through because of the word no error checking. A great method to use to conserve bandwidth. That would be another cut through because cut through is somewhat faster than star and forward. Then the destination NIC or network interface card discards any incomplete frames. So incomplete frames disregard, it means it would be store and forward. Then the faster switching method but may produce more errors, that would be cut through, because we all know that cut through is faster than store and forward, and somewhat store and forward is somewhat just a more reliable than cut through. But if you want to be fast error checking, that would be a cut through. Then but if you want a more reliable one, you should go to store and forward. Then there are two types of cut through, the free fragment and the fast forward. Then fast forward has the less overhead or other stuff. Then let's go to another one. Oh no, there's, sorry for that, please. This is the figure 2 activity. Then as you can see, cabling is used in the topology would be a straight through. Then to find where PC2 is located, we send a PC1 send a broadcast address. PC2 will reply with a unicast. Then if PC2 receive only, it will discard it. Then receive the damage for likely will change back to store and forward. Then let's check. So you can see all my answers are correct, and we're gonna move.